Thank you very much for casting your votes. Now, we are absolutely delighted to be joined today by the founder and CEO of Ingenero himself, Dr. Pratap Nair, who'll be sharing with us the company's exclusive roadmap for successful digital implementation in oil and gas. At Ingenero, Pratap has played a key role in developing and applying the digital twin concept for chemical process manufacturing as a key enabler for digitalization, using advanced analytics and technologies like first principle-based modeling, machine learning, AI, smart data platforms, and IIoT. He has a short presentation, which will be followed by a question and answer session, where you, our audience, will get the chance to ask him your questions on success in the next digital era. Our sessions are interactive, and we love to hear from you. So please do send in your questions in the chat box at the side of your screen. We're looking forward to hearing from you. But first, we're looking forward to hearing from Dr. Pratap. Welcome, Dr. Pratap. Thank you very much for joining us. And without further ado, over to you.
Thank you, Amanda. Let me just share my screen. And so before I start, let me give you a brief background of why we would be talking about this. Ingenero has been providing advanced data analytics and operations support to the oil and gas, refining, petrochemical, and chemical industries over the last 2 decades. As part of this, over the last 7-8 years, we have found that several of our clients have come to us and wanted to get us involved as part of their digitalization initiatives. And we have been deploying solutions for them the last several years. And so today what I will be sharing with everyone is some of the learnings that we've gone through, helping some of these clients out in this area. And so that's really what drove this whole topic, roadmap for successful implementation of digitalization. Before getting down into the topic per se, quick couple of slides showing you, where we operate as a company. We're headquartered in Houston. We have a large technology center in Mumbai, India. And we have clients all over the world, in the US, Middle East, the Far East, Europe, Africa. These are a sampling of some of our clients, and you'll see process manufacturers in there. You'll see service providers, and pretty much in the oil and gas, petrochemicals, and chemicals area. And we have deployed solutions for almost all of these clients, whether it's a support for the service providers or directly for the end manufacturing firms. So with that, let's get started at the very base. This introduction is always starts with the evolution of industry. We've had several industrial revolutions, as we all know, but we'll jump straight to the fourth industrial revolution. And that is something that has happened maybe in the last decade and a half. And that has been driven by increased computing power, communication, speed, data storage capacity, while there has been a sharp drop in the cost of each of these items. So that's really what kind of catalyzed, if you will, this whole industry 4.0 and the development of tools and technologies from that era, like the IoT, artificial intelligence, cloud computing, big data. Now, these are all tools, and people have tried implementing them. So today, where we are, is tools are all great, but you have to extract value from them in one way or the other. And so that's really where we are. And how do you extract that value? And that's really more of what I'll be focusing on today. And that's, again, based on our experience. So a couple of points that I will be taking up. One is the whole concept of augmented intelligence and augmented analytics, smart data, Internet of People, real-time solutions. So that's really things that I will be covering as part of this whole presentation. Let's start with augmented analytics. Now, analytics, we've had different kinds of analytics, over the years. And what has really changed is now the ability for providing real-time solutions based on these analytics. Earlier, some of these solutions would take a lot longer. It took orders of days, months, and then it went down to hours, and now you almost have real-time solutions. So augmented analytics, some of the key features are real-time solutions, utilization of artificial intelligence, machine learning, domain expertise is certainly important, and I'll really get into that. The end result is getting augmented intelligence that can help improve operations or improve whatever activity is happening. So now this type of analytics includes descriptive, diagnostic, predictive, prescriptive analytics that ultimately helps process manufacturers to take well-informed decisions. Let me talk a little bit about artificial intelligence. In the last few years, there has been a lot of hype about machine learning, deep learning models, and that has been equated to artificial intelligence. Yes, that is one of the subsets of artificial intelligence, if you will. But if actually people have been talking of artificial intelligence even way back in the 60s and 70s, and there the artificial intelligence work was mostly based on causal models, reasoning, rules. And now, with the industry 4.0, speed of computing and so on, we are now able to handle a lot more data. And so that's really where the machine learning and deep learning models and the whole techniques started really developing. It got a boost. Now, people have tried just feeding large amounts of data to these ML and deep learning solutions and trying to get results out of it. And of course, there have been some misgivings on that because it really takes time. A lot of learning is required to really start getting results. However, a lot of what has been learned over all these years, tens of years, centuries maybe, that has allowed us to build first principles. Interestingly, that has been built using small data. If you look at physics experiments, they're all based on small data, but over several hundreds of years, perhaps. So those first principles could be a learning assist, and it could reinforce the learning of the machine learning and deep learning models as well, in addition to just using the huge amounts of data. And that we have found to be very, very effective. So that combined with these causal models from the first principles and domain knowledge, that combination is really what forms artificial intelligence. So it's a combination of the two. And it's important to use both of these is what we've learned. Next thing is augmented intelligence. I've been talking about that. So really, when we talk of artificial intelligence, it's not today where we're talking of replacing the human being. The human being continues to have tremendous value. There's been a lot of debates in the academic world about artificial intelligence completely replacing the human intelligence. And they call it the point of singularity, but they say it's going to be 2050 or beyond. So how do we use this? Today, where we can very effectively use this is using these techniques to handle large multidimensional analysis, time-consuming analysis, time-consuming tasks, which would take the human being, the unaided human being, forever, or may not even be possible. So some of these rote tasks can be very easily taken care of by these AI systems. Now, once that is taken care of, it throws up a lot of insights and intelligence, which then the human being can start at a very different level. and use that for much higher productivity, much higher earnings, overall job growth, enhanced quality of the job. So that combination and of human intelligence, artificial intelligence providing the augmented intelligence to the human being to take it to a very different level. Well, that's the whole area of augmented intelligence, and that is really the application today of digitalization and so on to really for us to take advantage of that. Now, some of the things that we have learned and hence defining what a digital roadmap looks like. Before we start, let's look at what drives the need for digital. I've taken an analogy from psychology, the Maslow's hierarchy, which really talks about the various levels of human needs and what drives the human being. Without getting into details there, I'll go straight into the digital. You have different levels. You have digitization, which is conversion of information from analog to digital, which makes use of the data a lot easier, a lot more effective. Then you have the next step of digitalization, which is the whole process of taking the digitized data, automating processes. You take the data, analyze it, give access to the data and the information anywhere you want it. So the experts need not be where the data is. They could be halfway around the world. And hence utilization of this to improve working efficiencies. The next level is really taking this and transforming the business, what we call digital transformation, is really where using advanced data analytics, getting the augmented insights, adapting business processes, utilizing the augmented intelligence that you get to improve profitability. And all this actually enables us to actually set higher level goals for humanity in general, or even the business, things like sustainability. You're able to really do, maintain sustainability metrics, improve sustainability metrics with all this additional insights and information. And then you can actually set higher levels of goals. So that, I'm always intrigued by one of these, sayings, Dr. Ken Robinson. He's a very famous British author. I've always liked what he said. He says, for most of us, the problem isn't that we aim too high and fail. It's just the opposite. We aim too low and succeed. So obviously, the whole point is you need to set your goals, and obviously for digital solutions, that is required. If you're really happy and with the way things are, and you don't want to make any changes, obviously you don't really need to push for digital, right? So, however, when raising these aspirations, we need to be careful to remain grounded, because you also need to kind of pace it. So that's kind of a little bit about the needs. And then the roadmap broadly is you set your strategy, and the key, what we have found, is defining the use cases. People who are operating businesses, they typically know what their pain areas are and what possible opportunities are. So really defining that, and then working backwards and seeing, defining, okay, these are my key performance areas, key performance indicators. Then you go to the next step. Let's performance benchmark. Where are we operating with that today? Then you define, set your goals. Where do I want to push that? And then how do I use some of these tools and techniques that are there available today, using the digital technologies to enhance these goals and arrive at what we are trying to achieve. Of course, once we've got that set up as a solution, it is very important to often change the way we work. And so the change management associated with these solutions, we have found is very important if you really need to extract the value. And then, of course, track how you're doing, and that you are indeed getting the results. A little bit about the strategy drivers. Today in our industry particularly, data is not a problem. I mean, there's a lot of data that's collected, huge volumes of data collected at large velocities, tremendous variety. However, a key challenge is that the veracity of the data is always in question. About 20-25% of the data is always fraught with errors. However, I mean, the challenge is we don't know where those errors are. If you take 100 data points, it could be anywhere, right? So that's a typical big data challenge. Today, about 90% of its data is just archived. It's not even used. 10% tends to be analyzed. So that's typical small data. Now, when you look at the people running the business or the operations, they're constantly juggling with various challenges of maintaining throughput, productivity, maintaining yields, improving yields, maintaining quality, taking care of reliability issues, compliance issues. So solutions to all of these are really opportunities. And so that is where the digital comes in, utilizing more of the data, because it's in the 90% where you have a lot of the gems of information lying. And so that's really where, it's one of the drivers of digital and the basic strategy, if you will. Saying by Henry Ford there, if you always do what you've always done, you always get what you've always got. So that's the whole point. We can take digital and take it to a very different level. It's possible today with the tools and techniques. Now let's look at, we were talking of KPAs and KPIs, typical KPAs and KPIs from our operations in our industry. Obviously, profitability, compliance, reliability, quality, safety. These are all key performance areas. And then you have key performance indicators like furnace run length, overall equipment efficiency, cycle times, and so that's kind of some of these things that you really need to identify as a business. It may be different for different businesses. The hot buttons may be different. Identifying that, what makes sense for you is the key first step. And then defining, okay, this is where I am today with all these KPIs. This is where I could really be going to based on benchmarks. And what are the key factors that drive that gap? How do I get to the golden batch or the golden operation? That's, I may have operated very much better under similar circumstances before. But identifying that and being able to at least get there, even beyond optimizing. So that's the discovery portion. And then defining your goals. You set your KPIs, set goals. This is how much I would expect to improve. Set realistic goals, and then then you go into the delivery. And delivery is where it's really combining the right tools and techniques. Having the expertise and domain experience is very, very important. And this is something we've learned, through our past few years of working with digitalization and seeing some of the digitalization efforts at some places, haven't really gone as successfully as intended. Using of fundamental principles is equally important, along with things like artificial intelligence, machine learning. This is, again, something we learn. So being able to very effectively hybridize it and use it together is really where we start seeing very effective solutions coming out. The augmented intelligence that comes out of that allows for better decision making. Again, like I said before, making sure that you change the work processes to be able to utilize this augmented intelligence. Different way of working. If you continue to work the way you have, you're just going to automate inefficiencies, and you don't want to do that. So you want to take advantage of these new digital solutions and take it to a next level. And then, of course, tracking. You always need to track how you're doing with the objectives you set. Are you getting the results that you had intended? So these are basically, if you will, this is the roadmap, and this is what we found paying attention to these points has really helped the clients that, particularly some of the later clients we worked with, where we were able to factor these learnings and jointly work with clients to really, come out with faster, successful digital solutions. Now, let me tell you a little bit about Ingenero's approach. And this is, what we've implemented at several places. So I'll start with a few slides giving you a very broad look at what we do, and then I'll wind up with 3 or 4 demos at the end showing solutions that have actually been implemented at various businesses and sites. So the augmented intelligence solution, as we call it, our key piece is the intelligent software solution for process decision excellence. That's where the advanced analytics, that whole piece is there. But what is important, it's not just the algorithms. The algorithms have to be seamlessly integrated with the data, the data collection, the data storage, the IIoT, if you will, and then making that data available in the form of information that can be directly used for business decisions. And this is where the advanced analytics is so important, because if you use the raw data, the errors could skew what you're trying to get, and decisions could really go in the wrong direction. So that's the whole point. The advanced analytics integrated seamlessly with all these digital applications, collaborative solutions, business intelligence solutions, the data collection itself. That is really where the augmented intelligence that we spoke about before comes in. So if you look at the decision, one of the key points is, yes, there are tools and techniques from the industry 4.0. We've all heard about machine learning, big data, AI, and so on. So those are the tools, and they're like atoms. Solutions using these tools that can directly help you with solving a problem, or improving your performance in some way. That's the solution. So you weave together a lot of these tools, and so that's like a molecule. That's the analogy there. But going from the atom to the molecule, from the tools to the solution, requires a decision engineering step, which oftentimes is missed out. Certainly the data fuels all this, but that engineering piece, using multidimensional expertise and so on, is very important, and there's a work process to it as well. And so that's an important step. And of course, once you have the solution, it provides the augmented intelligence to the manufacturing teams, and that's really where the value comes off. Just a very quick glimpse at what we call iSpeed. Like I said, it's a seamless integration of various pieces of tools, MI, AI. You take the data, digitized data, utilize tools like MI, AI fundamentals, business intelligence, where you get your dashboards. It could be deployed on the cloud or on premises. It could be a hybrid. And then, of course, you have the decision engineering on top of it, making sure all this is pulled together and works along with the domain expertise and so on. So some of the typical features of iSpeed provides actionable intelligence. They are hybrid models, data historian agnostic, smart dashboards, it's an optimizer. Another very key thing is the false positive resistant. And this is where the combination of domain expertise with the machine learning really is helpful, because pure data with a machine learning model, oftentimes you get a lot of false positive alerts and things like that, which you really don't want, because the system could then go into disuse very, very quickly. Certainly, it's multidimensional, real time. There are soft sensors and so on. And so what basically it provides, accessible dashboards, making it more effective and efficient on the decision making. Various kind of dashboards for different levels for the management, providing more financial information, equipment overviews, overview of the plant for plant management, engineer level overviews, and so on. Quick case example. This is one of the organizations we worked with, and we started in about 2015 with them. This is one of the largest NGL pipeline network in the US. We set up these advanced analytics and digital solutions for them across 40 sites. And then, they took all this augmented intelligence, brought it to a central location, their headquarters, and they've got this single room where, it's like a space station almost. You have large screens with, you can pull up any facility or any combination of facilities and actually see the intelligence. And then you have the centralized team collaborating with each of these facilities to actually using this intelligence to augment the way they're operating. And this we found, had worked very effectively with this organization. They finally were selected as one of the, what they call the lighthouse facilities for digital solutions. They increased their profitability by 15% in the first year and reached almost 22% in the second year. So it was a very successful, digital solution implementation. And certainly there were a lot of learnings that came out of that. And they did address a lot of their initial issues that they were starting out to solve, like some of the quality issues, underutilization of capacity in these assets, and so on. So that is an example of one of the places where we worked with. So with that, let me just quickly kick into some of these demos. And these will just be auto run. I will just kick those off. There are various different demos. One demoing the management level dashboard. That's going to be the first demo. And so let me get started there.
Welcome to Ingenero. We offer engineering expertise and digital transformation solutions with machine learning and artificial intelligence data analytics. For an instance, we have recently made a dashboard for one of our clients which reports the management summary for their ethylene production plant. The data shown here are masked to protect confidentiality. We organize the dashboards for the ease of understanding of each department at every management level with effortless navigation. This report has the highlights section, which has the overview of a plant such as actual production compared with production target visualized in a radial gauge, the brief breakup of loss in production visualized in a waterfall chart, and major parameters to oversee the efficiency of the plant. One of the major segments in the highlights section is the notes segment. Here our process analytics engineer gives their observations and suggestions after analyzing the entire data sets, trends, process deviations, and anomalies. Then in further sections, we have reported each section in detail based on our client's interest. The next section has data related to specific consumption in detail. In this performance section, we have shown the trend of polytrophic efficiencies for different stages. One can choose the stages to be shown or hidden for comparison. Then in this constraints and flaring section, we have shown the parameters affecting the quality and quantity of production, so that the necessary actions to be made accordingly to overcome the constraints. Finally, in the equipment availability section, the client could see the detailed status of furnaces and equipment in tabular format with all required parameters. In future, we could add more sections like inventory, accidents, deviations, and energy intensity according to the client requirements.
Let's go to the next demo, which is shows you about some soft sensor applications.
Hi, welcome to the video. This video talks about Ingenero's Analytics and BI product. This product was built with an objective of extracting the maximum value out of the current assets and delivering value by adding capabilities of AI and ML at a very low cost. If you have an enterprise historian, our product leverages it to the maximum. Here is an example of how our product added AI/ML capabilities to an industry standard MES software that did not offer AI/ML capabilities in the MES suite. Soft sensors were built using ML models to predict product quality in real time. Additionally, a forecast of up to 2 hours was also a part of the prediction. This helped a customer to take corrective actions ahead of time to avoid product off-spec issues and also quality giveaway issues. Even a handful of such instances per year have a potential of saving millions of dollars. Additionally, customized business intelligence dashboards delivered real-time updates for this customer. It is a one-stop place for quick performance overview of plant, identifying key areas which need attention, live recommendations for corrective actions, analyzing the high-level monetary impact as well as technical details at operation level. Also, it offers different levels of views, which enable users to look into the level of details as per their requirement and time available.
And now this is another demo that shows an example of a real-time analytics solution that was done at an ethylene facility. Let's take a quick look at
Welcome. We will now give you an overview of Ingenero's real-time monitoring solution developed for ethylene facility in US. The software enables operators, shift supervisors, technology engineers and managers to use it as operations status tool. It provides in-depth technical insights driven by strong technical modeling based on artificial intelligence, machine learning, first principles and hybrid model techniques. Software is hosted on a robust and scalable software platform utilizing the latest software technology stack. We will first look at the elements of the user interface. On the left-hand side is the process tree providing drilled down from plant level to consoles, and then to individual equipment under each console. The middle section provide graphical view of the unit or console or equipment selected. Color of elements in the graphics will change based on the type of alert for that element. The right section provides the details of 5 features for the selected unit or console or equipment. These 5 features are namely dynamic benchmarking, equipment health, instrument drift, deviation tracker, and plant performance tracker. Dynamic benchmarking. The objective of this feature is to identify historical best operation for a given equipment, while ensuring that the historical best from last 3 years of operations closely matches with current operation of the equipment, but had a better performance historically as compared to its current operation. Graphs helps the user to understand when the performance of a transmitter was in alert stage with red indication, and when it got recovered with green indication. Furnace run length prediction. The software helps to understand number of days a particular furnace can run considering threshold of the maximum allowable coil inlet pressure. Software is self-iterative, and coefficients for predictions are evaluated and refreshed every 10 minutes. Here is the demonstration of value capture from live data Vertas for dynamic benchmarking feature, which has potential to save $0.7 million for one furnace run operation. In the future, Vertas can be developed for other individual units, which can be further extended to entire complex level to provide overall complex status and execute improvement potential through software solution. Thank you for watching this video.
Let's roll on to the next one, which is an example of a reliability application.
Hello, everyone. Welcome to Ingenero's machine learning-based reliability tool that covers 16 critical equipment of an ethylene facility. The reliability algorithm can run in real time as well as past dates chosen by the user. Equipment that have performance issues are flagged in red. For example, the quench tower in this case. Each equipment has detailed drilled down views. For the chosen date, several critical correlated operating variables like quench tower feed, steam, and feed temperature are tested for abnormal operation. Critical variables are flagged in red, and other top contributors to abnormal operation are also flagged in real time. In this case, the total steam to the quench tower has been reduced. Even though the absolute value of steam is normal, its relative value to the hydrocarbon flow is not normal. The relationship between propane feed to ethane feed and its ratio with steam is not normal operation. The combination of low steam to hydrocarbon ratio and high propane to ethane ratio has led to severe fouling in the past historical data. The ML algorithm has accurately classified the current operation as a bad operation and has pointed out the root cause for the abnormality. Thank you for watching this video.
We go to one final one, and this is actually a refinery example, and then we'll wrap up from there.
Hello everyone. Welcome to Ingenero Data Modeling Solution Tutorials, or in short IDMS tutorials. This is an introductory video to briefly explain the furnace module, which covers clean TMT and run length feature. TMT stands for tube metal temperature or skin temperature. So let's get started. Once you are signed into IDMS system, you will see IDMS system view. In this view, you can see different page options menu on the left-hand side pane. In Billings Coker unit, there are two furnaces. Furnace A is having pass 3 and pass 4, and Furnace B is having pass 1 and pass 2. To access the furnace module page, follow Equipment section, then go to Furnace and click on respective furnace page. Both furnace have similar user interface. Once clicked, Furnace module user interface will appear. Furnace module user interface is classified in two major areas, namely the central graphics and the right pane. The central graphics area contains graphical representation of coker furnace. The furnace graphic image contains colored circles corresponding to skin temperature indicators for each pass. Labels button is provided in the top right-hand side of the central graphics. This button is provided to toggle between two furnace screen views, Lean View and Detailed View. When Labels button is off, Lean View appears. The circles are clickable, and on click it will show the details of associated tag ID and values. When Labels button is on, Detailed View appears. Circles are not clickable. Tag ID and associated values will appear on the screen. The furnace module is divided into two categories, namely clean skin temperature and run length. Let's first discuss the clean skin temperature module. This module has been developed to predict clean skin temperature of all passes in real time. For any circle, yellow color numbers represent predicted skin temperatures, and white color numbers represent actual skin temperatures for that tube location. Circle colors are assigned based on extent of fouling. Green, yellow, and red color represents less, moderate, and high fouling respectively. A pop-up graph will appear after clicking on any tube skin temperature tag ID or value, in which actual and clean skin temperatures are compared. On this graph, x-axis and y-axis represent the time and the temperature respectively. Y-axis can be auto-scaled using y-axis auto-scale option, provided on the bottom left-hand side of the graph. Smooth and toggle button is provided on the top right-hand side of the plot to see 5 minutes data trend instead of daily average data. Trend duration can be changed from the available drop-down on the right upper corner of the trend. Let us discuss the furnace run length module. Furnace run length module is developed to predict furnace run length, and suggest changes in process variables to achieve optimized run length. Bar graph on top right-hand corner of right pane gives comparison of actual, predicted, and optimized run length for both furnaces along with furnace current status. Critical parameters table on the right pane displays the actual, predicted, and optimized run length along with expected EOR date. Actual furnace run length represents the actual number of days the furnace has been online. A pop-up trend appears on clicking predicted run length. Predicted run length can be trended with furnace operating parameters, which are available in drop-down and right corner of graph. A pop-up trend appears on clicking optimized run length, in which predicted and optimized run length are compared. Furnace fire duty is also trendable on click. Recommendations section below the critical parameter table will display the recommendations to achieve the optimized run length. Optimized run length is the maximum run length that would be feasible by changing process variables. Recommended process variable to achieve the optimized run length is shown by pink color, alongside actual tag value in the central graphic. Predicted and optimized run length are calculated based on end of run temperature input by user. To change end of run temperature, click on Target EOR temperature in bottom left corner of central graph. Please note that this option is available only for admin user level. On click, A pop-up window will appear to set target EOR temperature for individual furnaces. To update, select temperature value from drop-down for respective furnace, and click on Update. Once the target EOR temperature is saved, predicted and optimized run length will get updated. Additionally, in the central graphic image, all the white and pink numbers are trendable, and Tech ID with description appears as you hover on any value. Thank you for attending this tutorial.
So that's kind of gives you a glimpse of some of these. These are real solutions, applications that have been are being utilized at various facilities. So that's kind of what I had to say today. So thank you very much for sharing this, Amanda.
Thank you very much, Dr. Pratap, for sharing those really relevant insights. I think a lot of food for thought for our audience here. And that brings us onto our question and answer session.